Lubrication system. Function of oil review.
Lubrication. Ang pangunahing pag-andar ng langis ng makina ay upang malubricate ng mga gumagalaw na bahagi. Ang langis ay bumubuo ng isang film sa pagitan ng mga ibabaw ng metal na pumipigil sa pakikipag-ugnay sa metal na banggan at binabawasan ang kiskisan. Sumusunod ang nangyayari. Ang init na nabuo sa pamamagitan ng pagkiskisan. Nangyayari ang lokal na hinang. Ang paglipat ng metal ay nagreresulta sa scuffing o pagsamsam. Paglilinis. Ang langis ay gumaganap bilang isang ahente ng paglilinis sa makina sa pamamagitan ng pag-flush ng mga contaminant mula sa kritikal na bahagi. Ang putik, varnish at oxidation buildup sa mga piston, ring, valve stems, at seal ay haantong sa mabilis na pagkabigo ng makina kung hindi kontrolado ng langis. Ang langis na binuo na may pinakamainam na mga additives ay pananatilihin ang mga contaminant na ito sa pagsususpinde hanggang sa maalis ang mga ito ng sistema ng pagsasala ng langis o sa panahon ng pagpapalit ng langis.
Proteksyon. Ang langis ay nagbibigay ng proteksyon na hadlang paghihiwalay ng mga ditulad na metal upang maiwasan ang kaagnasan. Ang kaagnasan tulad ng pagkasira ay nagreresulta sa pag-alis ng metal mula sa mga bahagi ng makina. Gumagana ang kaagnasan tulad ng isang mabagal na kumikilos na mekanismo ng pagsusuot. Pampalamig. Kinakailangan ng makina ang pagpapalamig ng mga panloob na bahagi na hindi maibibigay ng pangunahing sistema ng paglamig. Ang lubricating oil ay nagbibigay ng mahusay na heat transfer medium. Ang init ay inililipat sa langis sa pamamagitan ng pakikipag-ugnay sa iba't ibang bahagi pagkatapos ay inilipat sa pangunahing paglamig sa oil cooler. Silang. Ang langis ay nagsisilbing combustion seal na pinupuno ang hindi pantay na ibabaw ng cylinder liner, piston, valve stem, at iba pang panloob na bahagi ng engine. Shock dampening. Ang oil film sa pagitan ng mga contacting surface ay nagbibigay ng cushioning at shock dampening effect ay mahalaga sa mataas na load ng mga lugar gaya ng mga bearings, pistons, connecting rods, at gear train. Hydraulic action. Ang langis ay gumaganap bilang hydraulic media sa loob ng makina. Ang mga halimbawa nito ay ang paggamit ng langis upang paandarin ang mga preno ng makina at mga tapot ng injector ng STC. Ang langis ng makina ay dapat nabuuin sa paraang hindi ito bumubule bilang resulta ng mga proseso ng mekanikal na agitation na nauugnay sa maraming pag-andar nito. Ang foamed oil ay nagreresulta sa pagkasira ng makina na katulad ng oil starvation dahil sa hindi sapat na oil film protection.
Oil plays a vital role in engine operation and lifespan. Engine oil's four primary functions include lubricating, suspending contaminants, dissipating heat, and acting as a hydraulic fluid for internal engine components. Lubrication represents oil's primary function. Inside the engine, moving parts generate friction. Oil reduces friction between these surfaces by creating a narrow film of oil molecules. This oil film reduces friction and heat. Oil also isolates and suspends harmful contaminants between oil changes. By suspending these particles, every oil change flushes this damaging material out of the engine. Oil also protects against rust and corrosion by coating all internal engine parts, preventing oxidation. As oil flows through the engine, it also removes heat from friction points isolated from the cooling system. Finally, vehicles use oil as a hydraulic fluid, engaging such components as VTEC rocker arms, VTC actuators, and the cam chain tensioner. In order to lubricate all the moving parts of the engine, all oil systems use common components. A typical system uses a pump to move pressurized oil throughout the engine, and then gravity returns oil back to the engine's sump to circulate through the engine again. In this section, we'll review these components. The lubrication system uses a positive displacement oil pump to pressurize engine oil passages. Some pumps mount at the front of the crankshaft, while other engines drive the pump using a chain connected to the crankshaft. The pump assembly includes a relief valve designed to limit total system pressure. The relief valve opens if oil pressure exceeds spring pressure due to extremely low temperatures or a blockage in the oil passages. When open, the relief valve directs oil back to the oil pan. From the oil pump assembly, oil flows to an oil filter. Inside, filtration media traps contaminants such as dirt or metal particles. If allowed to circulate in the oil system, these contaminants can cause wear on the bearing surfaces of the engine. Contaminants may be the product of combustion or an internal contaminant. Products of combustion include soot, carbon particulates, unburned fuel, and water. When oil remains in the engine too long, these contaminants overload the oil's ability to handle them and forms a coating called sludge. This sludge covers internal engine parts, blocks the return path to the oil pan, and reduces lubrication performance. Internal contaminants consist of metallic particles, spent oil additives, sulfuric acid, and nitric acid. These contaminants increase wear on moving parts, leading to greater friction, reduced oil pressure, and component failures. Some contaminants can plug the media inside the oil filter. When this occurs, the oil filter allows less oil to flow to the engine and reduces oil pressure. To prevent a blocked filter from starving the engine of oil, the oil filter includes a bypass valve. Should the filtration media block too much oil flow, the bypass valve opens, allowing unfiltered oil past the blockage. While the oil filter removes solid contaminants from the engine crankcase, the positive crankcase ventilation, or PCV system, removes gaseous contaminants. These contaminants include combustion gases that leak past the piston rings and water vapor formed through condensation. The PCV system draws in filtered air and uses engine vacuum to send crankcase vapors into the combustion chamber. This reduces sludge formation and helps increase engine oil life. Some engines use an engine oil cooler at the filter to transfer heat into the cooling system. One coolant line delivers coolant to the oil cooler, while a second line sends the coolant and heat into the engine water jacket. From the oil filter, engine oil travels through oil passages. Manufacturers machine each engine part so that oil passages match up from component to component. Because of this, always consider oil passages when positioning gaskets during engine assembly. In some cases, an oil passage includes an oil control orifice. This device reduces oil flow when installed in an oil passage. Whenever you disassemble an engine, keep track of these orifices. If you replace a block, be sure the new block has the correct oil control orifices, or transfer the orifices from the original block to the new engine before reassembly. Most oil passages end at a bearing. Bearings typically include a wear surface on the rotating component and a bearing surface. The bearing surface may be a machined surface on the component or a replaceable bearing shell. Between the two components, a tiny gap allows a narrow film of oil to isolate the parts. To deliver oil to this gap, bearings include a hole in their face. From this delivery point, oil fills the space between the shaft and bearing. From here, oil drains from the bearing edge and returns to the oil pan. As the oil flows from the friction surface, it removes heat and impurities. When assembling engines, make sure the oil hole in each bearing correctly matches the oil passage. If an oil passage on the bearing is in the wrong location, no oil flow occurs and the bearing will fail. A few oil passages end with oil jets, located on the block underneath the pistons. These oil jets spray oil into the cylinder to lubricate the cylinder walls and cool the piston bottom. The final system component is in the cylinder head, where oil passages feed oil to cam-controlled solenoids. When energized, these solenoids hydraulically operate VTEC pistons or a VTC actuator. Oil system faults include oil leaks and pressure problems. Oil leaks occur due to faulty mating surfaces, defective seals, and cracked or porous engine castings. Oil pressure problems include low pressure caused by wear, low pressure from low oil levels, or excessive pressure readings caused by oil system blockages. Problems in the oil system start with the basics. For instance, the correct oil fill level is critical for proper oil system function. Too much oil can interfere with crankshaft rotation. This can aerate the oil, leading to low oil pressure and possible engine damage. Excessive oil can also cause idle vibration, power loss, or even limit engine RPM. Finally, excessive engine oil may increase crankcase pressure, forcing oil out of the engine through seals or gaskets. Low oil level causes different symptoms. Hard braking or cornering can expose the oil pickup, drawing air into the oil pump and dropping system pressure. A low oil fill also reduces the system's ability to dissipate heat, increasing overall crankcase temperatures. For all of these reasons, always check the engine oil level before further troubleshooting.
Lubrication system. Function of oil review.
Please like, share, follow, and subscribe to my YouTube channel. Thank you.